Alright, so we're going to talk about some inverses because a logarithm is the inverse of an exponent, okay? One of them undoes the other. You know, like adding and subtracting are inverses, they undo each other. Multiplying and dividing are inverses. Exponents and logarithms are inverses. One of them undoes the other, okay? So let's just look at the exponents just really quickly. This is a basic exponential function, 2 to the x. If you put in a -3, you get 1/8. If you put in a -2, you get 1/4. So it stays right here, goes up. What are you never going to get on this? Where's it never going to go? So you think about this. I can put in any number I want for x. The domain is all real numbers. What about the range? It's never going to be 0. It's never going to be a negative. Because remember, when I'm doing that exponent, that's 2 times 2 times 2 times 2 times... Am I ever going to be able to get 0 multiplying times 2? No, I can't. I can't repeat 2 enough to get 0. So I'm never going to have negatives. The range is all positive numbers. The y-intercept is 0, 1. If I can't get to 0, then there's not going to be an x-intercept. That means there's a horizontal asymptote at y equals 0. It's always increasing. As x approaches negative infinity, the function approaches 0. It's not going to touch it. It's going to get infinitely closer. And as x approaches positive infinity, f of x also approaches positive infinity. So those are just some things to remember about that function right there. Okay? Now, if you look at this, remember that when you do an inverse of a function, you just switch the ordered pairs. What was xy, change it to yx. So let's switch this. Okay? The first point that we had was -3, 1/8. Let's write 1/8, -3. What's the next point that we had on page 774? So let's write 1/4, -2. And then let's see, we had -1, 1/2. So what am I going to write right here? 1. What's going to go here? Well, right. So those are the values for the inverse of f of x. Now let's graph. Let's graph this. Yeah, 1/8, -3. I'm really going to be able to graph that on this board. No, up and down a little bit. 1/4, -2. 1/2, -1. 1, 0. 2, 14. Is this a function? Yeah, passes the vertical line test. There's a function. Now, it does, like right through here, what's happening? If we were to describe it by hand, it probably wouldn't look like it's passing the vertical line test. But what's happening right here as it goes down? Yeah, it gets closer and closer and closer, like infinitely closer. But is it ever actually going to touch it or line up with it? No, it's just going to be so close, we can't tell. Like when we look at it, we're not going to be able to tell. But it's not. It's going to get infinitely closer. Okay, so it is a function. Passes the vertical line test. Alright, so I want us to keep looking at this graph, but we're going to answer question B. So I'm not going to scroll up to question B because I want us to see the graph. Okay? So what's the domain for this graph? What's the domain for this graph? Positive numbers. Yeah, the domain is that x is going to be greater than 0. What's the range? All real numbers. Remember, we just traded domain and range, right? So if you look over on page 774 where it says the domain is all real numbers, that's going to be the range on the inverse. And it said that the range is all positive, so that's going to be the domain on the inverse. You just switch your domain and range. Intercepts. What's the x-intercept? What is it? 1, 0. X-intercept is 1, 0. Is there a y-intercept? No. Okay. What did you ask for? Areas of increase and, oh no, it didn't ask for asymptote. So what is the asymptote? What is it forever getting closer to, but it's never going to touch? The y-axis, which the line for that is x equals 0. So the asymptote is x equals 0. And areas of increase and decrease, well, it's forever increasing. Increases over the domain. And the last in the haze. Alright. So x is not exactly, x is not approaching infinity. X is approaching 0. The graph is approaching negative infinity. And then, but it is approaching, when it goes this way, it is approaching infinity. A little bit more infinity. That's it. So they're just inverses, okay? One undoes the other. They're switch, flip, whatever, however you want to say it. I don't know if it's flip. They're switch, reverse, reverse, I don't know. Alright, we're going to skip a page and go to where it talks about logarithms. Maybe that's skipping 2 pages, I don't know. Skipping that page. 777? Yep, right there. Yeah, this is a super lucky page. As long as you sit on this page, earthquakes can't get it. Right? Yeah? No? For 8 weeks, they're going to stay on this page. Alright, so, the inverse of an exponential function is a logarithm. Okay? And, this is really important right here. If y equals b to the x, okay, to write it as a logarithm, x equals log base b of y. That tells you where everything goes and how to rearrange it and everything. I'll give you just a second to write that down and we'll talk about it. Okay, remember, these are exponential functions. These are basically problems where the variable is the what? The exponent, right? The problem is the exponent. Or the variable is the exponent. I need to figure out what the exponent was. What did you do? What power did you take this to get that number? So I come up with something. I come up with some sort of operation where what was the exponent is now the answer. See, a logarithm tells you what that exponent was. It goes from being the exponent to being the answer. You say, well, I took this number to the x power, and I got this number. Really? Okay. So I'm going to take the log with the same base, because remember, both of these are, that's called a base. That's called a base. Okay? Well, I'm going to take the logarithm of that number, and it's going to give me the exponent. You are just undoing what you did. Okay? Both of these are still bases. It's called a base. Here's some examples. Here's some examples. Oh, yeah. Logarithm or exponent, base. That's called an argument. Of them written back and forth. Okay? Here they are written back and forth. Like 4 squared equals 16, right? We all know 4 squared is 16. You all know that, right? 4 times 4 is 16? Yes. Awesome. Okay. So if I wanted to write that as a logarithm, log base 4 of 16 is 2, or 2 equals log base 4 is 16. You can put that equal sign on either side. You know that, right? So 10 to the third is 1,000. The base is 10, so it becomes the little number. The exponent becomes the answer. And what was your answer becomes the problem. (16), 1.25, 32. See where it goes there. Okay? Alright, we're going to try to rewrite some for just a second. Let's rewrite some. Okay. If it's in exponential form, like a and b are, write it as a logarithm. If it's in logarithmic form, like c and d are, write it as an exponent. Can you see c and d? Do I need to rearrange this now? Okay, let me do this. Is that better, people in the back? Okay. So what's this one going to look like? 2 equals, yep. Log base 5 of 25. That's right. Have that? Awesome. Alright, what about this one? Base 6 to 16. Yes. That is correct. How about right here? Yes. And this one?
3 to the 5
Fantastic. There you yes.
Like where it says 216, would you have to put parentheses around that?
You do not. Okay? Alright, any questions about this? Any more questions about these 4 problems? Go back to the book for a minute. Okay, come on now. Okay. Let's look at this one for a second. So this is the graph of h of x equals b to the x. Sketch the graph of the inverse and label the coordinates. And well, they've given us all the points, right? So all we have to do like this one is 0, 1. What's the new point going to be? 1, 0, right? This one is 1b, so it's going to be b1. So I'm going to go over b units, and I'm going to go up 1, right? Which should be like right there. What's it going to end up looking like? If you graph this, what will this graph look like? It looks just like the other one did, right? If this is h of x equals b to the x, what's the inverse of it? What's the inverse of all exponential functions? A logarithm. And what's the base here? B. And then we're just going to use x again because we don't know what we're talking about here. We're just going to use x. That's our inverse. Right there. Oh, we did just write the equation. It's right there. So do you think all exponential functions are invertible? Do all exponential functions have an inverse? Do they all have an inverse? Will all exponential functions pass, remember, if the original function passes the horizontal line test, then it has an inverse function that'll pass the vertical line test, so it does have an inverse. Do all exponential functions pass the horizontal line test? Yeah, because what's happening right here where it looks like it's going to fail? What's actually happening? Right, it's still moving. It looks like it kind of bottoms out, but it doesn't. It just gets closer and closer, infinitely closer. Kind of makes your head want to explode. Think about it. Don't though, because if it does, you should clean up your mess. I don't clean up head explosions in here. Alright. So we've talked about exponential functions. A logarithmic function is a function involving a logarithm. There are two frequently used logarithms. One is a base of 10 and the other is a base e. Common logarithm is a logarithm with a base of 10. And if you see a log written like this, where there's no base indicated, that's 10. It's a common log. It's 10 and we don't write it. This is the one your calculator will do. Your calculator will do this one and this one. It won't do, like if you do log base 7, your calculator, well, some of your calculators might. Because some of you got fancy calculators. But your calculator won't do base of 7. It'll do base E and it'll do base 10. Natural log is a logarithm with a base E and it's usually written LN. Okay? LN. Notice yesterday when we were using e to the x, it was over the natural log because they're inverses of each other. Okay? Can I erase this and move it? Is everybody still underlining or highlighting it? Yeah, some people are. I'll wait a second. Are you done? Ooh, I don't know if all right. So let's talk about this Richter scale again. I don't know what page this is. Yes, I do. 781. Alright, so the Richter scale is used to rate the magnitude of an earthquake, or basically the amount of energy that's released. An earthquake's magnitude, M, is determined by the equation M equals the log of I over I to the 0. Or not I to the 0, I sub 0. Sorry. Where I is the intensity of the earthquake being measured by amplitude of the seismograph reading, taken 100 kilometers from the epicenter of the earthquake, and I sub 0 is the intensity of a standard earthquake or special earthquake whose seismographic amplitude is 10 to the negative 4 N. Okay? So determine the magnitude of a standard earthquake. A standard earthquake, the intensity of a standard earthquake is 10 to the negative 4. So it's I would be 10 to the negative 4, and on the bottom you always put 10 to the negative 4. What's anything over itself? 1. So we're looking at the log of 1. Alright, so log of 1. That's what we're looking at, right? What's the base here? It's a common log. There's no base, so what's the base? 10. Basically, I'm saying 10 to the x equals 1. What power do you take any number to make it equal 1? 0. So the magnitude of a standard earthquake is 0. I don't think we're going to do the division next, because this next problem will take us about the entire class through. Look at your pages that you tore out.